Welcome back to section 1.8, part 3. These are some additional practice problems. Composition of functions always causes some trouble, so it's good to do extra practice, and that's what we're doing right now. So f of g of x, like I said, I kind of like the old notation. I think it's a little bit easier to follow. So function f at the input of x plus 3 over 2. So for function f, it's 2 times x, so it's going to be 2 times, leave it blank, with some grouping symbols, minus 3. In that open spot, that's where we substitute our x plus 3 over 2. All about substitution. And now we're going to simplify. Now you see the 2 on the outside and the 2 on the inside, one's in the numerator and the denominator, they cancel out, so we're left with x plus 3 minus 3, which in the end we get x. So that's f of g of x. Looking at our domain, look at the inner function first, no restrictions. Look at the outer function, and what happens here is there's no restrictions, so our domain is all real numbers, or in interval notation, negative infinity to positive infinity. G of f of x. So it's going to be the function g at f, which is 2x minus 3. So for function g, it's the quantity of x plus 3. So instead of writing x, we're going to leave it blank with some grouping symbols, plus 3, all divided by 2. And in those parentheses, that's where we substitute r, 2x minus 3. So we get rid of our grouping symbols. It's 2x minus 3 plus 3 over 2. The 3's cancel, so it's 2x over 2. And 2 divided by 2 is x. So g of f of x equals x. Next, to find our domain. Inner function, no restrictions. Final function, no restrictions. So our domain, we can use any real number we want to, negative infinity to positive infinity. Problem number 7 next, on the next page. F of x is the square root of x, and g of x is x minus 1. We're going to have some restrictions here. I can tell already when I see that square root. So we have f of g of x. So it's f of x minus 1. So for that function f, it's the square root of x. I'm going to leave it blank, and that's where I substitute my x minus 1. That's f of g of x. It's the square root of x minus 1. Now, when we look at our domain, there's no restrictions for our inner function, but our final function, we can't take the square root of a negative number. So underneath that square root should be x minus 1. We should set it greater than or equal to 0, because it has to be a positive number or 0. So we add 1 to both sides, and you get x is greater than or equal to 1. So that's our restriction. So for our domain, thinking about our number line, we have a solid dot at 1, and we're greater than that, so we're going in towards the right. So our domain would be 1 with a bracket towards positive infinity with a parentheses. There's our domain for that function. And next, g of f of x. Like I said, these are all about substitution. So the function g at, instead of f of x, the square root of x. So the function g is x minus 1, so it's the square root of x minus 1. And that's it. That's all we can do. There's g of f of x. So for our domain, for our inner function, we have the square root of x. So since we're taking the square root, it has to be greater than or equal to 0. So x must be greater than or equal to 0 when we have the same restriction for our final function as well. So if we think about graphing that on the number line, here's our 0 with a solid dot, and we're going to the right. So our domain would be from 0 to parentheses, bracket at the 0, parentheses at the infinity. Number 8. F of g of x first. So it's going to be the function f at the square root of 1 minus x. So when we substitute that in, it's x squared. So it's leave it blank, squared plus 4. Now underneath it's going to be the square root of 1 minus x. Now when we square that square root, they undo each other. So left with 1 minus x plus 4, which is going to be 5 minus x. That's f of g of x. Now when looking at our domain, in our function first, we have a square root of 1 minus x. So 1 minus x has to be greater than or equal to 0. Because we can't take the square root of a negative number. So what I'm going to do is I'm going to subtract 1 from both sides. Negative x is greater than or equal to negative 1. Divide both sides by negative 1, x, and then 1. Now remember, when working with inequalities, when dividing both sides by a negative or multiplying both sides by a negative, you have to switch the inequality sign. So it becomes less than or equal to 1. If you think about our number line, here's the 1. Less than, we're going to the left. So our domain for this is going to be negative infinity to 1. Parentheses at the negative infinity, bracket at the 1. If you're not sure if your answer seems correct, you can always substitute a value in and make sure it works. Remember, it has to work for the inner function as well as the final function. If it doesn't work for the inner function, it doesn't exist right away. G of f of x. So the function g at x squared plus 4. So the function g is the square root of 1 minus, and then in that open space, x squared plus 4. So we're going to distribute the negative 1 minus x squared minus 4. So it's going to be the square root of negative x squared minus 3. That's g of f of x. Now for our domain. Inner function, no restrictions. Outer function, we could possibly have some restrictions with that square root. Remember, square root, when you see that, or an even root, set what's inside, negative x squared minus 3, and in this case, greater than or equal to 0, because we can take the square root of 0. So now I'm going to add 3 to both sides. I get negative x squared greater than or equal to 3. Divide both sides by negative 1, x squared less than or equal to, switch the inequality sign, negative 3. Now when solving a quadratic inequality like we have here, I'm going to set x squared equals to negative 3, but then when I take the square root of both sides, I get x equals. Now we cannot take the square root of a negative number. We're going to get plus or minus I root 3, if you remember that, which is imaginary. It's not real. Since it's not a real answer, there's no real number that's going to cause us to have a negative under the square root. So our domain for this case, since our only restriction would be an imaginary number, is all real numbers. It's going to go from negative infinity to positive infinity. That's our domain. That's a tricky one. And then let's go to problem number 9. F of g of x, so it's going to be f of the square root of 9 minus x squared. So it's going to be, instead of f of x, we're going to put x squared, so leave the parentheses blank, squared minus 9. And in that, we're going to put the square root of 9 minus x squared. We're going to substitute. So when we square that square root, they cancel each other out. We're left with 9 minus x squared minus 9. So f of g of x is going to equal negative x squared. That's our final function. Finding the domain, look at the inner function first. In this case, we have the square root of 9 minus x squared. So 9 minus x squared greater than or equal to 0. I'm going to subtract 9 from both sides, so I get negative x squared greater than or equal to negative 9. Divide both sides by negative 1, and that gives me x squared is less than or equal to 9. Now it is a quadratic inequality, so I'm going to treat it as x squared equals 9 for right now. I'm going to solve that. X, take the square root of both sides, so you get x equals plus or minus 3. Now, graphing it, here's my negative 3, here's my positive 3. Now I go back to my original, my inequality. X squared less than or equal to 9. I'm going to use solid dots for both because it's or equal to. I'm going to pick a test point in between. I'm going to test x equals 0. So what I get is I get 0 squared less than or equal to 9. 0 is less than or equal to 9. That's true. So our shading is in between. So our domain, our values that we can use for x, are going to be between those 2 points, from negative 3 to positive 3. That's the domain for that composite function. And finally, the revenue function for this problem, r of x is x times f of x. So f of x is 50 minus 0.05x. So r of x is going to be x times 50 minus 0.05x. So r of x is going to be, when we distribute, 50x minus 0.05x squared. There's our revenue function. Now the profit function is the revenue, r of x, minus the cost of x. The thing to be careful with here, p of x, the revenue function, 50x minus 0.05x squared, minus the quantity of 0.09x plus 12,000. Remember, be careful with your grouping symbols. Make sure you include them there. So it's 50x minus 0.05x squared. Distribute the negative minus 0.09x minus 12,000. So the profit function, p of x, is going to be negative 0.05x squared plus 49.91x minus 12,000. That's the function that would give you the profits at any value of x, the number of units sold. That is it for composite functions and working with functions. See you in the next video. Thank you.